Section 2.2 in your textbook is the section on circles. When we are looking at the equation of a circle, or when we're thinking about what a circle is a set of points that is equidistant from a single point, where that single point is the center of the circle, and that distance that every point is from the center is called the radius of that circle. In general, from the distance formula, your book shows you where the equation comes from. But what's called the center radius equation of a circle looks like x minus h squared plus y minus k squared, those quantities squared, is equal to r squared. And again, that does come from the distance formula. The center of our circle is located at the ordered pair hk, and of course r is the radius of the circle, where radius is the distance from the center out to the edge of the circle. So if we're given the equation of a circle and it's already in the center radius form, maybe I have x minus 2 quantity squared plus y minus 1 quantity squared equals 9. Then from that equation, we can pull out the coordinates for the center. If this is x minus h, then that means h is a positive 2. We have x minus positive 2 there. And if this expression is supposed to be y minus k quantity squared, then I know k is positive 1 because I have y minus positive 1 here. Also, if r squared is equal to 9, then that tells us the radius of our circle has to be the square root of 9 or equal to 3. If I want to sketch a graph of a circle, if I know where its center is and I know what its radius is, then I can start at the center and go from there. So understand that the point 2, 1 is not officially a point on the graph. The graph is the set of all points that are 3 units away from that point. But if I think of this as my starting point, then I can go 1, 2, 3 units in any direction and be on my circle. But the easiest directions for me to move in a rectangular coordinate system are in the rectangular directions. So up and down, left and right. If I go up 3 units, down 3 units, left 3 units, and right 3 units, and then try to connect those so they look like a circle, sort of. That would be a graph of the circle x minus 2 quantity squared plus y minus 1 quantity squared equals 9. Now again, remember that the point 2, 1 is not officially a point on your graph, but again, that was the point that we used so that we could measure and figure out where the graph of that circle would lie. Sorry. So if we have the equation x plus 3, that quantity squared, plus y minus 4, that quantity squared, equals 1, then the center of that circle, if this is x minus h, that means we can really think of this as being x minus negative 3. So our h is going to be negative 3. And if we have y minus k, then that means k is going to be positive 4. And we know if r squared is equal to 1, then when we take the square root of that, it's going to tell us the radius of our circle is equal to 1. When you are pulling the center from the equation, and that equation's in the center radius form, pretty much the pattern that we follow is we're going to change the sign. The center is going to be at negative 3, positive 4. So again, the point negative 3, positive 4 is not officially a point on the graph, but we need to have it there so that we can kind of use that as a guideline to figure out where our circle is. And if the radius is 1, then we can move up 1, down 1, left 1, and right 1 to get to points on our circle. And then connect the dots so it kind of looks round. So this blue graph is the graph of the equation that we started with. All right, let's look at the equation x minus 2 quantity squared plus the quantity y plus 3 squared equals 16. Go ahead and pause the video, see if you can figure out where the center and the radius of the circle are, where the center is, what the radius is, and then sketch yourself a graph of this. So pause the video, do it, and then when you turn it back on, I'll show you what the answer is. The center of the circle, if we change the sign and change the sign of our expressions, our center should be at 2, -3. The radius of this circle is going to be 4, which is the square root of 16. If we go to the point 2, -3, and think about that as being our starting point, I know I need to go 4 units up, 4 units down, 4 units left, and 4 units right before I connect the dots and sketch a graph of my circle. Make that look like it's really 4 units every direction. Now if we want to go backwards, sorry I keep doing that, if we want to go backwards and they give us the center is 1, 2, and the radius is 3, and we're asked to write the center radius form of the circle, we just say x minus h quantity squared plus y minus k quantity squared is equal to r squared. So of course I'll call that a 9 instead of a 3 squared, but otherwise this is center radius form. Your book talks about standard form of a circle, and I don't care about you taking it from center radius form to standard form. If you're interested in that, all that means is we're going to FOIL both of these out and put all of our terms on the same side and mix them all together. And again, this is what I'll quiz you over, that's what I'll test you over, is to see if you can get to center radius form of that circle. Now, unfortunately, they don't always give us our equation in that form already. Still getting used to this tablet, so I'm sorry my writing's kind of crazy. So this would be an example of an equation given to you in standard form. And maybe I want to know what the center of this circle is, or what its radius happens to be. But it's not written in the form where I can just pull it out of the formula. If I want to take something, so again, my goal is to make it look like this. So if I have something that's not a perfect square, and I want to make it into something that is a perfect square, then this is where I'm going to get to complete the square. We talked about completing the square back in chapter 1 when we were solving quadratic equations, and we said, well, yeah, it's good to know how to do that. This is a good place to start, but it's not something you would ever have to be able to do. We have things like the quadratic formula and factoring that can help us on the problems. Well, here in circles, and then at the end of chapter 2, when we, beginning of chapter 3, when we look at quadratic functions, we don't have any other options. We get to complete the square. So just like we did with quadratic equations, we put our x squared and x terms together and moved our constant to the other side. But since we have an equation in 2 variables now, we get to do the same thing with the y's. So we'll regroup x squared and x terms, y squared and y terms, and move the constant that we're given to the other side. Now remember, when we complete the square, we're going to take half of that term and square it. So if I take 2 divided by 2, I get 1, and 1 squared is 1. Now I can add anything I want to here as long as I also add it to the other side. Anything I want as long as I do the same thing to both sides. Then we come back and do the same thing with the y's. Half of negative 4 is negative 2. If I square it, I get 4. And if I add 4 to one side, then I have to add it to both sides. Then when I go to factor the expressions, they should factor as perfect squares. The two numbers that multiply to get 1 and add to be 2 are 1 and 1. The numbers that multiply to be 4 and add to be negative 4 are negative 2 and negative 2. And then if we combine all of our terms on the right, we get a 9 there. Now we're in center radius form. We can say the center of this circle is at negative 1, 2, and the radius is going to be equal to 3. If I wanted to sketch a graph of that, I could take some time and sketch a graph of that circle. I'm going to set up one more, and then you can pause the video. Oh, let's not put them in that order. And try it on your own. So let's look at x squared plus y squared plus 6x minus 8y minus 2 equals 0. So pause the video, go ahead and try to complete the square twice on this one, put it in center radius form, and then turn the video back on and see if you were right. When I complete the square, I want to get my x squared and x terms, my y squared and y terms together, and move the constant that was given in the problem to the other side. The number that I'm going to add to my x terms to complete the square is 9. Half of 6 is 3. 3 squared is 9. And what I add to one side, I have to add to the other. Doing the same thing with the y terms gives me a 16 to add to both sides. And then I go back and I'm ready to factor. X plus 3 squared plus y minus 4, that quantity squared. And on the right, I have 27. Now, in some of your problems, you're not going to have nice whole number values for your radius. The center is negative 3, positive 4. And if the radius squared is 27, that means the radius is the square root of 27. Now, just like any other time you have a radical, you need to simplify it completely. So we'll pull the 3 out and a 3 stuck underneath. There's my radius, there's my center. Now I'm going to stop here with this lecture because the video is getting long enough that that probably I've already lost most of you. But go ahead and watch this, watch it more than once if you need to, and then come see me or ask questions in class on Wednesday if you have questions I need to clear up. For your homework from section 2.2, I'd like you to start with problem 3 and go to 15, counting by threes. And then I want you to come over to problems 25, that says 5, through 28, and do all 4 of those. Now notice on some of the problems, like on number 24, there are things like 9x squareds there. Here's one with a 9 or a 4 or something on that one. Okay. If you're practicing and doing extra problems, you can do those if you read the section. But again, I've left out what to do if there's anything other than a 1 in front of the x squared or the y squared terms. Okay, so if you're doing extra odd problems, stick with the ones that start with 1x squared and 1y squared, or go back and read the section and see what they tell you to do with those numbers.